question. Question number 3. Alright, so the question reads, if y varies inversely as to x and y equals 8 when x equals 4, find y when x equals 16. Okay, so the phrase y varies inversely relates to our concept of proportions, okay? So the proportional notation is this, and whenever we have this notation here, we say that y is somehow related to x. In this case, we say that y varies proportionally to x. That means when x grows greater, or x increases, y also increases. So when it means y varies inversely to x, that means that y is proportional to 1 over x. So when x grows bigger or increases, y grows smaller. And when y grows smaller, x grows. When y grows bigger, x grows smaller. Okay, so that's what it means when it says y varies inversely. Okay, so in the question itself, it stated that so we know that there's a proportional relation between y and x, and there's an inverse proportion. Okay, so given that, and given an example of this, find the relation between y and x. Okay, so from here we have to understand that the proportion between the inverse proportion between y and x is not necessarily 1 to 1, right? So we have to consider the fact that there might be a constant that also varies between these two. So, right, so from here we can write that y equals constant k times 1 over x. So we're maintaining the inverse proportion, but we're also considering the fact that there might be a constant that scales this relation, right? And from here, we can use the information that we're given by the question itself to find the constant, and through that, we'll be able to find out y when x equals 16, okay? So from here, we sub x equals 4 and y equal 8 into our thing, and this is what we get. So a equals k times 1 over 4. Okay, so now we're going to isolate for k. So we're just going to move our 4 over. So we just multiply both sides by 4, and we get 4 times 8 equals k k over 4 times 4, and we get k equals 32. So now we have found our constant k, and we can plug it into our relation. So therefore, y equals 32 over x. And now we can solve for y when x equals 16. So when x equals 16, so sub x equals 16, y equals 32 divided by 16, which is 2. Therefore, y equals 2 when x equals 16, according to y equals 32 over x. Right? So that's how you would be able to solve this kind of question. So we covered the fact that what an inverse proportion is, or an inverse relation is, which means when x increases, y decreases. And a really good example, if you want to graph this, is your reciprocal function here, right? So if I were to graph this inverse proportion relation, all I can say is, if this is the x and y axis, this is what an inverse proportion looks like, right? And also we have a negative side here, but we won't cover that for now. We see here as x increases, y decreases, and when x decreases, y increases. So this is what we call an inverse proportion, and that's what this is entirely. And by doing so, we also have to consider the fact that there might be a constant that relates between y and x. So we have to solve for this constant before we even try to solve for our actual question here. So we found our constant, which is 32. We actually found our relationship, which is y equals 32 over x, and we subbed in x equals 16 to find what y equals to, and y equals to 2. So this solution is correct. Cool. All right, let's move on to question number 4.